Hello everyone, welcome back to my channel. I'm Muskan from Sri Venkateswara College of Engineering, currently pursuing my bachelor's in computer science and engineering in cybersecurity. Today I'm going to present on the topic pointer variables and double pointers. Introduction. Pointers play a crucial role in C programming as they provide a way to manipulate memory directly. Understanding pointer variables is essential for efficient memory management and data manipulation. So what is a pointer? A pointer is a variable that stores the memory address of another variable in programming. It allows indirect access to data, enabling dynamic memory allocation and efficient manipulation. Let's see the declaration and initialization of pointers. Pointer declaration. To declare a pointer, we use the asterisk or dereference operator before its name. We only declare the pointer, but we do not initialize it. Here, it's the data type int, asterisk, and the pointer name. This is how we declare a pointer. Pointer initialization. We generally use the ampersand or address of operator to get the memory address of a variable and then store it in a pointer variable. Pointer initialization is the process where we assign some initial value to the pointer. Here, we are assigning the value of 10 to a variable var of int data type. Then we are declaring a pointer of int data type. And now here this pointer stores the address of this variable. So when we print this variable, 10 will be printed. So in the future, if we change the value of this variable to 20 or 30, the same will be printed whenever we print this pointer. Pointer dereferencing. Dereferencing a pointer is the process of accessing the value stored in the memory address specified in the pointer. We use the asterisk or dereferencing operator that we used in the pointer declaration. So this is our variable which has the value 50 and the address of this variable is 1001. And this is a pointer PTR which stores the address of this variable which is 1001. So this is how a pointer points to the variable, but it stores the address of the variable. So whenever we change the value will be changed without any problem. And whenever we print this, we are going to get the changed value. So let's take an example to demonstrate the use of pointers by swapping two numbers to understand this concept better. So here we have void swap. This function, what it does basically is it swaps x into y and y into x. So when in the main function, we give the values of x as 10 and y as 20, and we put the addresses like ampersand of x and ampersand of y, which is the address of x variable and y variable here. So when this goes, when we execute this program, the output will be 20 and 10. The numbers will be swapped. So x is 10 and y is 20. But when we run this program and the pointers get exchanged, then we get 20 and 10. Dynamic memory allocation. Dynamic memory allocation in C involves allocating memory during program execution. This flexibility is achieved using functions like malloc to reserve memory and free to release it when no longer needed. Pointers play a crucial role in dynamic memory allocation. By using pointers and functions like malloc, memory can be reserved for variables runtime, providing a dynamic and adaptable approach to memory management. Let's learn about double pointers. So double pointers in C are variables that store the memory addresses of pointer. They add an extra level of indirection, offering a way to manipulate pointers themselves, enabling dynamic memory allocation and more advanced data structures. So the syntax of double pointer is the data type, two asterisks, and the pointer name. Here, dereferencing of double pointer. Asterisk pointer name is a single pointer and two asterisks in pointer name represents a double pointer. So a double pointer stores the address of a single pointer and a single pointer stores the address of a variable. So here the single pointer gets the address stored in the inner level pointer, and this the double pointer gets the value pointed by the inner level pointer. It's a bit confusing, but it is a very nice concept. Let's see the declaration and initialization. The declaration of pointer to a pointer or a double pointer is data type of the pointer, two asterisks, name of the variable, and ampersand to allocate the address, and the normal pointer variable. Here, in the example, we see the data type is int, the variable we give the value as 5. We are defining a pointer here, which will store the value of VAL, which is 5, and we are defining a double pointer here, which is storing the address of this pointer. So a single pointer stores the address of the val to the pointer PTR, and pointer to a pointer is declared here, which is storing and pointing to the integer 5. So here the first pointer PTR stores the address of the variable, and the second pointer dPTR stores the address of the first pointer, as I told before. Let's see an example of a double pointer. So here, what we're doing is we are giving a variable, we are assigning the value 789. Then we declare a pointer, which is of int data type, and the name is pointer2. And we declare a double pointer, which is also a data type, and the name is pointer1. So here, pointer2 is equals to ampersand of variable, which means it is storing the address of the variable in pointer2. And then pointer1 is equals to ampersand of pointer2, which means pointer1 is storing the address of pointer2 in pointer1. So when we display all the variable, the single pointer and the double pointer, we get the same number. So the value of variable is 789. The value of variable using single pointer is also 789, and the value of variable using double pointer is also 789. So how double pointer usually works is you define a variable. So this has the value 10, and 2008 is the address of the variable. So the single pointer, it stores the address of the variable. So pointer 1 is storing the address of the variable, and this 4020 is the address of pointer 1. So our double pointer will be saving the address of pointer 1, so which is 4020. So a pointer to a pointer of variable will be storing pointer 1's address, and the pointer to variable will be storing the address of the variable. And the actual variable with the value here is 10. Let's learn about the size of double pointers. A double pointer behaves similarly to a normal pointer in C. So the size of a double pointer variable is always equal to a normal pointer. The size of a pointer is not fixed in C programming language. It depends on other factors like CPU architecture and OS used. Usually, for a 64-bit operating system, the size will be 8 bits, and the 32-bit operating system, the size will be the 4 bytes. Let's see some application of double pointers. They are used in dynamic memory allocation of multidimensional arrays. They can be used to store multi-level data such as text document paragraph, sentences, and word semantics. They are used in data structures to directly manipulate the address of the nodes without copying. They can be used as function arguments to manipulate the address stored in the local pointer. Let's see the importance of pointer variables. Efficient memory management. Pointers allow dynamic memory allocation, enabling programs to adapt to varying runtime requirements efficiently. Advanced data structures. Proficiency with pointers is essential for implementing and manipulating advanced data structures like linked lists, trees, and dynamic arrays. Optimized performance. Proper use of pointers can lead to optimized code, reducing memory overhead and enhancing overall program performance. So in conclusion, proficiency with pointer variables and double pointers in C is foundational for efficient memory management, advanced data structure, and optimized performance. Mastering these concepts empowers programmers to enhance functionality, prevent memory issues, and excel in diverse programming scenarios. Thank you for watching.